So we're asked to find the sum of the first 50 terms of this series. And you might immediately recognize that it is a geometric series. When we go from one term to the next, what are we doing? Well, we're multiplying by 10 elevenths. To go from 1 to 10 elevenths, you multiply by 10 over 11ths. Then you multiply by 10 over 11ths, 10 over 11 again. And we keep doing this. And we want to find the first 50 terms of it. So we can apply the formula we derived for the sum of a finite geometric series, and that tells us that the sum of, let's say in this case, the first 50 terms, actually let me do it down here. So the sum of the first 50 terms is going to be equal to the first term, which is 1. So it's going to be 1 times 1 minus, let me do that in a different color, 1 times 1 minus the common ratio. So the common ratio here is 10 elevenths. 10 elevenths to the 50th power, to the power of how many terms we have. All of that over 1 minus our common ratio. And so I'm not going to solve it completely, but we can simplify this a little bit. This is going to be 1 minus, and let me put parentheses here just to make sure we're not just taking the 10 to the 50th power. So 1 minus 10 elevenths to the 50th power over, this is 11 elevenths minus 10 elevenths is over 1 over 11. And so this is the same thing as multiplying the numerator by 11. So this is going to be equal to 11 times 1 minus 10 elevenths to the 50th power. And you could try to simplify this even more, but this gets us pretty far. At this point, it is just arithmetic. Let's do another one of these. This is kind of fun. So this is more clearly a geometric series. And let's just first think about how many terms we're going to take the sum of. You might be tempted to say, okay, I'm going to take it to the 79th power. There must be 79 terms here. But be very careful, because the first term is when we're taking things to the 0th power. We're taking 0.99 to the 0th power. The second term is where we're taking it to the first power. The third term is where we're taking it to the second power. The fourth term is where we're taking it to the third power, so on and so forth. So this right over here is the 80th term. 80th term. So we want to find S sub 80. And so this is going to be equal to our first term is going to be 1 times 1 minus our common ratio to the 80th power, all over, and I'm leaving a blank because we still need to figure out our common ratio, all over 1 minus our common ratio. So at first, you might say, well, maybe the common ratio here is 0.99, but notice we have a change in sign here. And the key thing is to say, well, to go from one term to the next, what are we multiplying by? Well, to go from the first term to the second term, we multiply by negative 0.99. And then, so we're multiplying by negative 0.99. Now to go to the next term, we're again multiplying by negative 0.99. So the common ratio is not positive 0.99, but negative 0.99. So let me write that, negative 0.99. And of course, that is going to be to the 80th power all over 1 minus negative 0.99. And so we could simplify this a little bit. This is all going to be equal to, well, that 1, we don't have to worry too much about that. And so this is going to be 1 minus, so negative 0.99 to the 80th power. Actually, let me put parentheses there to make sure we are taking the negative 0.99 to the 80th power. Well, we're taking it to an even power, so it's going to be positive. So that's going to be the same thing as 0.99 to the 80th power. And all of that over, well, subtracting a negative, that's just going to be adding the positive. So all of that over 1.99. And we could attempt to simplify it more, but if we had a calculator, we could actually find this exact value, or close value, actually. Most calculators don't give you the exact value when you take something to the 80th power. But this is what that sum is going to be. Let's do one more of these. All right, so here we have a series defined recursively, And so it's useful to just think about what it would actually look like. So the first term is 10. And then the next term, so the second term, a sub 2, is equal to a sub 1 times 9/10. Right? So the next term is going to be the previous term times 9/10. So it's going to be 10 times 9 over 10. And then the next term is going to be the second term. The third term is the second term times 9/10. So 10 times 9 over 10 squared. And the way it's written right now, I haven't written it as a finite a geometric series. So let's say we want to take the sum. Let's say we want the sum of first, I don't know, 30 terms. Sum of first 30 terms. So what will this be? Well, we're going to take s sub 1, s sub 30. I don't know why I wrote 10. S sub 30, the sum of the first 30 terms, is going to be equal to the first term. We've done this before. The first term times 1 minus the common ratio. 1 minus the common ratio to the 30th power. All of that over 1 minus the common ratio. And let's see, we could 1 minus 9/10. This is 1/10 right over here. You divide by 1/10. That's the same thing as multiplying by 100. So this is going to be 100 times 1 minus 9/10 to the, well, let me write it this way, 9/10 to the 30th power. And actually these parentheses, you always want to, so I can put parentheses there, just make sure we see that we're taking both the 9 and the 10, or the 9/10, the whole thing, to the 30th power, not just the 9. So there you go. Yep, there you go. We're done.